Okay, today we are talking about solving multi-step equations. So equations that take more than one step. Now we are taking 2 days on this lesson. However, the video will we're only taking notes for 1 day. So that's kind of nice. So, got our name on here. Multi-step equations. So it's going to bring back those single and double step or 2-step equations, and then we'll just add a little bit more, dig a little deeper. So it says some equations contain expressions with grouping symbols. So that would be something like a fraction, or with numerator and denominator, or with parentheses or brackets. To solve these, we either expand the expression using the distributive property, which is something we tend to never forget, which is fantastic, or we can divide by the number outside of the parentheses or in front of the parentheses, and it kind of simplifies the equation. But that method only works nicely if one side of the equation has the parentheses. And then we're going to combine like terms and solve. So you'll see what I mean by nicely here on the next couple slides. So on slide 1, it has 15 times the quantity, 20 plus d equals 420. Well, this 15 is being multiplied by everything, so if I wanted to, I could undo the multiply everything by 15 by dividing by 15. And that would leave me with 420 divided by 15 on the right-hand side, which is a solid 28. We would bring down what's left in the parentheses. And then this is a one-step equation. So we would, instead of adding 20, we need to subtract 20 from both sides to get the variable by itself. Makes a 0 pair, and we get 8. So that's one method. The other method, which a lot of us jump to right away, nothing wrong with that. This one, the one I just showed, is kind of a shortcut, really. We could distribute the 15 to the 20 and the d, which means multiply. 15 times 2 is 30. Add that 0 plus 15d equals 420. Now this is just turned into a 2-step equation. Subtract the 300 from both sides. Bring down our 15d equals 120. If we were to divide both sides by 15 after that, we would end up with d equals 8 again. So two different options, but only if one side has a set of parentheses and the other side is just a constant. So in letter A, again, we have just one side with a parentheses or grouping symbol and then a constant on the other side. But I'm going to go ahead and I'm going to distribute this one. So negative 3 times 9 is a negative 27. A negative 3 times a positive x is a negative 3x equals 33. You could write this as plus a negative, but I think that's silly to write plus minus. So we have a negative 27 out here, so I need to add 27 to both sides to get rid of it. Remember that this is a negative 3x to bring down. And this would be 10, so that makes this 40, 50, 60. Dividing both sides by negative 3 would give us x equals negative 20. We would have ended up with the same thing if we had divided by negative 3 first, but that trick only works sometimes. So I'm going to go ahead and show you more distributing. A couple of vocab, so if you have your vocab sheets, you can pause me to write this down. So the number of solutions. So the number of solution, we're going to have 3 options. We can either have the null set, which means there's no solution, one solution, which looks like x equals something, some number, or infinitely many solutions, called the identity. So those aren't your vocab words yet. Your vocab words are down here. So equations with no solutions are called the null set. So that kind of looks like that. And we'll go through some that solve that like that. We've been working with things with one solution for right now, or up till now. You could also write that as empty set, and you could use the symbol like a 0 with a slash through it. That's what I will use. Sometimes I do an empty bracket set, but I don't really use that. Other equations may have every number as their solution, meaning like this one, where 2 equals 2, or x equals x. So if it equals its mirror image, it's called the identity. So an equation that is true for every value of the variable is called the identity. So you can pause it and write those down. So we're going to move on to some multi-step equations that could have those. So if you notice the format between slide 2 and slide 4, lots of different stuff behind the equal sign, that means we can't use this dividing trick because it would mess everything up. And if you're curious about that, I can help you later. So what we're going to end up doing is we're going to end up distributing everything we can. So 6 times x is 6x. Bring our subtraction sign down, 18. Bring our down, our plus 10. Equal sign. 2 times 3x is 6x. 2 times negative 4 is negative 8. I'm going to combine all the similar terms. Negative 18 plus 10 is negative 8. So I get 6x minus 8 equals 6x minus 8. If I want to get my x's over here, I would subtract 6x here. Oh, look, they both go away. So I get negative 8 equals negative 8. Well, when something is equal to itself, if you look over here, something equal to itself, it's called the identity or infinite many solutions. So you can write either one, identity or infinite. I might end up going between both of them. I kind of write both of them. We also might have noticed that is true. We could have stopped here because we got the same thing on both sides of the equation. Let's look at 3. Distributing first. Remember, when you distribute to both. 8 times 4 is 32. Bring our subtraction sign down. 8 times 2 is 16. X equals 12 minus 20x plus 4x. No common terms to rewrite or to combine, so I'm going to rewrite that below. 12 minus 20 is negative 8 plus 4x. Okay, so now we need to combine, we want to get our x's over here probably. So subtract 4x on the right and subtract 4x on the left. So I got 0 here. I have 32 minus 20x equals negative 8. Need to get rid of this 32 by subtracting the positive 32 from both sides. I get 0 here. Negative 20x equals negative 40. Divide by negative 20. And we get positive 2. So that's just one solution. So if we looked over here, null set, one solution, identity, we just found a one solution. We're pretty used to that. Let's try a couple on the back. The word problems are where this gets tricky. Let's distribute. 3 times 6, 18, minus 12x equals negative 12x plus 18, negative, positive when you multiply. So if you can see it, maybe you can see it already, but we've got to add 12x to both sides because I want to bring all those x's over here. Well, if I do that, I end up with 0 x's on both sides, and I get 18 equals 18. Which was the identity, or you can write infinite, your choice. It means that whatever you plug, infinite means whatever number you plug into the left side will give you that same number on the right side. That's basically what that means. I could have stopped here because I noticed I have a positive 18 and a negative 12 on both sides, but if you don't recognize that, you can go all the way down to this step. So let's do the same distributing over here. 2 times 3x is 6x plus 10. Nothing else. Okay, so I've got 10x minus 20 minus 4x. So if I combine nothing over here, 10x minus 4x is 6x minus 20. So now I need to get all the x's over here. So if I subtract 6x from both sides, I end up with 0 x's, and I end up with 10 equals negative 20. Well, can that ever be true? No, so I put a not equal sign through here. I can put a 0 with a slash through it, meaning empty set, or I could write null. So those are the two things that would be acceptable in the box. All right, we have a couple word problems, and then we're done. So sometimes these word problems, you got to reread them a couple times so that you make sure you understand what's going on. It says Mel is 3 years older than Rafat, and Auriello, wow, is twice as old as Mel. The sum of their ages is 57. Well, sum tells me we're going to have to add something up, and it's going to equal 57. So it didn't tell me anything, really. It just says Mel is 3 years older than this person, and this person is twice as old as Mel. So what I like to do with these problems is write down what I know. I've got a Mel, I have an R, and I have an Aurelio. It says Mel is 3 years older than this guy. I don't know how old this guy is, so I'm just going to call him X. If Mel is 3 years older than him, that would be X plus 3. and Orello is twice as old as Mel. So if I need to take this times 2 means I need to set it in parentheses. The sum of their ages is 57. So if I add all of these up, I'm actually going to distribute this one so that I know that it's a little bit easier. Less parentheses. So if I add all these up, I have x plus 2x is 4x. 3 plus 6 is 9. So I could rewrite this equation as 4x plus 9 equals 57. And now it's just a two-step. So I subtract 9 from both sides. I get 4x equals 48. Dividing by 4, I get x equals 12. We're looking for Mel's age. This is this guy's age. Mel is x plus 3, so 12 plus 3, or 15 years old. That's Mel. The one we found was Roffit. And Orello is twice Mel's, so must be 30. Last but not least, you'll see something like this on your homework, where you have a little chart there. The table shows the number of students in each homeroom. Write an equation to find the number of students in Mr. Boggs' homeroom if the total number of students is 90. So we know that the total is going to be 90, and we just need to add these up, if you can kind of see them. We've got a b, a 1.5 times b plus 2, a 15, and a 2b minus 9. So I'm going to distribute this one, and actually 1.5 times b is 1.5b. 1.5 times 2, or $1.50 times 2 is $3. So now I can add up all my b's. b plus 1.5 is 2.5, nothing there, 3.5, 4.5b. Now my constants. No constant here, 3 here, 15 here is 18. 18 minus 9 is 9. So we just added all those up, all those constants. So the final equation, or the equation that we're going to solve, is 4.5b plus 9. So solve the equation to find the number of students in Mr. Boggs. So I'm going to just write that down here. Subtract 9 on each side. This is just a two-step equation. We've been working with these for a while. 81, divide both sides by 4.5. So 81 divided by 4.5 is 18. So B is 18. Is that Mr. Boggs? Luckily, B is who belongs in Mr. Boggs, so the number of students in Mr. Boggs' classroom would be 18 students. We can use that to figure out every other teacher if we needed to. And just make sure on your homework you know exactly who it's solving for. All right. Every champion was once a contender that refused to give up. Have a great day.